Okay, we're gonna give this a shot. Recording this. This is the first part of the study guide. We stopped at we started at number 20 yesterday, so this will be 1 through 20, and then we'll see where we go from there. But basically, let me move this out of the way because I don't think this is anything. Number 1, so naming angles in 4 different ways. Okay, so this is one angle. So it's not 4 different angles, it's only one. And remember, an angle is like, you can think of it as like a door hinge, if that helps, where you've got a ray here and, let's say the door is shut and, the ray's going this way, and then you open it up and another ray to where this angle opens up, okay? Now along the way, there's several ways we could stop. We could, as we're going up, we could have the angle open up that much, and if I put a line here, or a ray here, now I've formed, there's 3 angles up there. There's this angle, and then there's both angles still together, okay? So, depending on how much you open it up is what we're dealing with. Now, there's only one angle, okay? There's only one angle, it's right here. And we can name it, though, 4 different ways, okay? So the first way is angle 7, okay? That'd be the easiest way. If they give us a number, if they give us that option, we can name it that. Another name that we can name it, because there's only one angle there, is angle M. Okay, had there been another angle there, we couldn't call it angle M anymore, because now there's 2, there's 3 at angle M, and we don't know which one we're referring to. Okay, then the other 2 ways we can name this one is by its letters, so LMN, and we have to go in that order, meaning we can't just say NLM or something like that. We've got to go where we make the vertex the middle number, or middle letter. Okay, so LMN. The other way we could go is turn around and go the other way, though, NML. So questions on that? You kind of have that as far as the 4 different names for it?
Yeah.
Okay. Then it says identify its vertex. So what's the vertex up there? Remember what the vertex is?
Is that the M?
The M. So the vertex is M. Okay, so you'll put that on your paper because it says identify its vertex. You can just put V equals M. So you'll want these 4 names. These are the 4 names. Okay, and then you'll want vertex as M. And then its sides, how many sides does it have?
2.
2. And they're the rays, okay? So you got to name them like a ray. An array, you have to name it by its starting point and then go the direction towards the arrow. So MN, that's one of the sides. You put the arrow and it always goes to the right. The arrow always goes to the right. That's why you have to start with the starting point. The other side, then, start at the starting point again, go towards the arrow, is ML. And even though it's going up, because we named it that way, ML, in that direction, we still point the arrow to the right. You will, and that's a test question too later. If you see a choice that says something like, even if it said ML and had an arrow going like this or something like that, the arrow cannot go that way on the symbol for ray. It's always got to go to the right. So it gives you a heads up for that. So that's number 1. So you got the 4 names, you got the vertex, and the 2 sides. So that's a possibility of 7 points because it's got 7 different answers. So number 2, so go ahead and tell me what would be one name for number 2.
The 8.
Okay, angle 8.
P.
Okay, angle P.
QPO.
Okay, QPO. One last one.
And OPQ.
Very good. Okay, those are the 4 names. The vertex is P, and then the side is PO and PQ. Okay? Alright, so that's naming. You're gonna have to do at least 3 or 4 of those on the test. So as long as you got that down, I mean, that's a lot of points. As long as you get that down and make sure you know how to name. That's one of the most basic things that we're doing with this, to make sure we know how to name an angle. Okay? All right, so then we get into a different type of question. So that one, there's just, those two right there, there's just one angle and we're naming it in different ways. Now, we have more than one angle at a vertex, and they want us to name all the angles. So no longer are we naming an angle 4 different ways, we are now naming different angles. Why is that a big difference? Because, I'll give you an example here. Okay, they want you to name all the angles that have Q as its vertex. So here's Q, you got several angles here, Q is the vertex. We're naming all the angles that have Q as its vertex. So if I name one of them, angle 1, that's one of them. Okay, so there's one of your answers. I'm not going to turn around and rename that angle again. Okay, they don't want me to name the angles in every possible way. So I'm not going to turn around and say, okay, another one is UQV. That, I don't need to name that one. I've already named it. UQV is 1.
Oh.
So I don't need to name it twice. Over here we did, because they want us to name the same angle 4 different ways. Here they just want us to name the angles. So once you name it, you're done. You don't have to, you don't have to turn around and then call it VQU and UQV and 1, and you're just naming it once. So I will say this, if you use this, if you go ahead and use that, that's fine, you're not gonna be wrong, but then don't turn around and also name it angle 1, okay? Now I choose the easiest. How do I always lose my erase? I choose the easiest, which is angle 1. So instead of that, I would use angle 1 because that's the easiest way to name that angle. So what's another one up there?
2.
Angle 2, okay? Now is that the only 2 angles that are up there? Kind of looks like it is, doesn't it?
But it's probably not.
But it's not, all right? So you know something's up, but you're not quite sure. Angle 1, angle 2, that's 2 of them that we can see easily. But remember, take this, so let's start here. Let's say our door closes here. Okay, so we'll start with this right here. Okay, kind of block out the rest. I wish I had I knew how to use that. So just take this ray by itself, right? And let's say we're opening it up, okay? There's one of the angles that we named, okay? And then we started with this as its door and opened it up here, and that's the other angle we named. But what about if we just, now, remind you that this is an angle, but also if you combine them, and kind of look at it without this there, that's a whole nother angle, right? That's an obtuse angle that's there. Now we can't call it 1, 2. We can't combine it with numbers. So we have to use the name, or we have to use the letters to name it. So I'll put this back, because once you see it, then you gotta even see it with that line there. So I'm calling the angle that opens up from here to here. So what would one name be? You have 2 choices.
UQW.
Very good. UQW. UQW. You could have called it WQU. So there's 3 angles there. Even though it kind of looks like there's only 2, there's this one by itself, this one by itself, and then both of them combined.
Okay, so what do we do with the V? Nothing.
With the what?
The V. Is that a V?
Right, no, yeah. Because we named it 1, we don't,
Oh.
yeah,
Okay.
yeah. You could have called, instead of 1, you could have called it UQV.
Okay.
You wouldn't be wrong, but I'm trying to drill that you don't name that same angle twice.
Gotcha.
So once I name it there, then I'm done with that. Okay? Number 4. Same thing. but now it's kind of turned a little bit. It's kind of facing this way, but it's really the same problem, just different letters, and it faces a different way. So now you've got pretty much the same thing, it's just facing this way and it's different letters, but you got angle 3, you got angle 4, and then you've got 3 and 4 combined, which you could call XQZ.
Or can you do ZQF?
Yes.
Okay.
Yep. So those are your 3 angles there.
Okay.
Same problem, just looks a little different. 5 has more options. Okay, they keep building here. Okay, let's see, this is A. This is Q. Every time I use that marker, it hits me in the nose. 5, 6, 7. Okay. So here's the letters, there's the numbers, and now I've got way more than just 3, okay? So let's go through and name them all. First off, we can still name the ones by their numbers. So angle 5, angle 6, angle 7. If you can do that, you've got half the problem right. So that's good. You know, at least do that. You got 5, 6, and 7. Now, same concept that we can combine angles, but now we can combine even more angles, okay? Let's say you combine just 5 and 6 together. That's a totally different, like if this one's 40 degrees and this one's looks like about 20 degrees, okay, we've already named the 20-degree one and we've already named the 40-degree one. But what about when you combine them both and have a 60-degree angle? That's these here, right? That's a 60-degree angle. So that one, we can't call it 5, 6, but we can call it AQC.
That's where I'm confused.
Okay, well, let me trace it with a different color. Okay, here's angle 5. Okay, that was this one, 40. Here's angle 6. That was this one, 20. But now, we are combining these two. Okay, it's 60 degrees, so it goes from here to here. It's 5 and 6 combined. So that is AQC.
Okay.
Or you could have called it CQA.
Alright, but only one or the other, right?
Right.
Okay.
Yeah, once you pick it once, then you're done with that.
Okay.
Okay? Now, okay, I'm going to try to erase just the red. Well, let's see, let's go back over. Okay, so we're back to our original. So I combined 5 and 6. Let's say this is a 45-degree angle. And those are off because that would be bigger, but just for our purposes. So we've combined 5 and 6. What other two numbers could we combine?
6 and 7?
6 and 7. So that's going to be this angle. Okay, that's combining 6 and 7 together. So that one is called BQD. Okay. Now, if you think about it, we named a 40-degree angle, a 20-degree angle, a 45-degree angle. Then these two together were 60, and then these two together were 65. Okay? So they're all different sizes. They don't have to be, but in this case, they're all different sizes. Is there any other angle up there that you see?
I was wondering about AQD.
AQD. That's 5, 6, and 7 combined. That's a totally different angle. So far we've got 40, 20, 45, 60, 65. If you combine them all, That's 105. That's a totally different angle. So that is this whole angle, all of it combined, and that's AQD. Now that's all of them. You can't combine, now we combined 5 and 6 and we combined 6 and 7. Why can't we combine 5 and 7?
Because we're leaving out the middle.
Middle, can't leave a gap, okay? So, very good. So that's it, that's all we're doing with that. Just probably seeing it in different colors maybe helped a little bit. You can do that. I told the students yesterday, if you're dealing with something like this, especially when you get to like the ones we were doing yesterday on number 20, where it uses the same shape over and over for each problem, draw it as many times as you need to in pencil, and then erase what you don't need, right? Because that's part of the problem. You see all of it, and you may only need to use this part of it. Well, just erase all the rest, and it helps you visually see what you're working with. If you redraw it in pencil and do that, and if, like in my case, you could use colored pencils so that you could use different colors to kind of help it stand out. You can do that. There's no problem with that. That's part of working, a geometry problem. You can use your own drawing, recreate it and erase what you don't need to see. Okay?
Okay.
Number 6, okay, interior, exterior are on the angle. Do you know what we're asking there? Like those are pretty, the number 6, the dot is in the interior, the point is on the interior. Number 7 is on the exterior. Okay, it's on the outside. Number 8 is actually on the angle. Okay, so those are pretty self-explanatory. Okay, then we get into linear pair and adjacent. Which are linear pair, which are adjacent?
And that's where I get.
Okay, and that was, I think that was what we covered yesterday. No, we covered that Monday. Yesterday we did vertical and I think just vertical was the new one yesterday. So this would have been from Monday. So here, first off, we need to read all the directions. Now when they put a little M, like M1 equals 45, all that's meaning is the measure, they use that to abbreviate measure. The measure of angle 1 is 45 degrees. So they're giving you information that you're gonna need, okay? So let me draw all the pictures up there. Oops, that's terrible representation of that. There, that's better. And then they have, that's one of the drawings. And then another drawing is, okay, and then they have this one. And then they have, I thought I had a purple. I do have a purple. What is that? That's a T. Okay, so a couple things they tell us. They tell us that measure 1 is 45, so this is a 45-degree angle. You can go ahead and put, I put them in there so you can see. Measure 2 is 135. Okay. Measure 3 is 125. Do you see where I'm getting these? Where they read? Okay. Measure 4 is 45, so that's over here. Measure 5 is 135. 6 is 35. And CAT is a right angle, which they already told us that by putting that little box there. Okay, that little box means it's a 90-degree angle. Okay, all right, so there's all the information given to us. Now we got to determine if these are true or false statements. Okay? So they want us to tell, they basically ask us about linear pair and adjacent. So we have to go back to our definitions. Linear pair means it forms a straight line. Okay, there's a pair of them. So there's two angles that form a straight line. And then when I defined it, I said they have to be adjacent. Okay, and they have to add up to 180. Now, adjacent means, to go back even further, adjacent means that they share a vertex, they share a side, and they can't be inside of one another. That was something else we talked about yesterday because, you know, we were dealing with an angle that looked like this, and this one was inside of it, and so they said, is this angle adjacent to the full angle? You know, is one adjacent to this whole thing? And I said, yeah, they share a vertex and they share a side, but you can't live adjacent to someone and live inside their house. You can't live, you know, say that you live next to them and actually live inside their house. So one was not adjacent to this angle here. It's inside of it. Okay, so those were the defining things of being adjacent. It has to share a vertex, share a side. So let's go through and see if these are linear pair and adjacent. Now 1 and 2, okay, here's the thing. You could say, yeah, they add up to 180. You know, if you combine these two, they add up to 180. They almost look like they form a straight line. But remember, linear pair have to be adjacent. They have to be connected. They have to be adjacent. These don't share a side or a vertex. So no, they cannot be a linear pair. Okay? Now this question isn't asked on the study guide. So we can determine that they're not a linear pair, they're not adjacent, but what would they be? Are they any of our definitions? Now you don't have to put this, they're what?
No, there's not, is it? No, I wouldn't think so.
Well, remember we also talked about so I'm gonna put these up here, linear pair, adjacent. We also did complementary, supplementary, and we did vertical. Now, the one you missed yesterday was vertical. But remember the definition of supplementary is they just have to add up to 180. They don't have to be adjacent. And so that would fall in the category of supplementary. It would be, they do add up to 180, and they're not adjacent, so they could be supplementary. Okay, number 10. Do 4 and 5 form a linear pair?
No,
Why not?
because it doesn't have the, because it has to have the 2, doesn't it? I don't know what the,
Well, they share a vertex.
right, they share a vertex, but it doesn't have this, like a second line.
Well, do they share this side? This is one side of 4.
Oh.
That's also the side of 5.
So yes.
Yes. Yeah. And when they're connected like this, and they share this side, and they add up, they still have to add up to 180 though, and they do, then yes, they are a linear pair.
Okay.
Here's this, see, this would be like, here's angle 4. This is the roof of angle 4, right? Here's angle 5. This is the side of angle 5. So they do share a side.
Gotcha.
Yeah.
Okay.
So that's true, they are a linear pair. Okay? Number 11, are 6 and 3 adjacent? Now here's the thing, they kind of share a side here, right? They're sharing this side.
You only share one side?
Well, it's okay to share one, they only have to share one side,
Oh.
but they don't fully share it. And then remember, adjacent has to share a side, and they have to share a vertex. Here's 6's vertex, here's 3's vertex. So they don't share a vertex.
Okay.
So they are not adjacent. Okay, 7 and 8. Here's 7. Okay, let me put it this way. Here's 7's vertex. Right, this is where angle 7 has a vertex. This is also where 8 has a vertex. Okay, here's angle 8. Here's angle 7. Is there a line? Do they share? Yeah, they share this side. So they share a vertex, they share a side. So yes, they are adjacent.
And 13's
Now here's 13. This is the one I was talking about inside. is CAT, okay, here's CAT, so it's this angle here, it's the full angle. 7 is inside of it, and they're asking, are they adjacent? Now, remember, they do share a vertex, they do share a side, they share this bottom, but 7 is inside of CAT,
You can't live.
so you can't have one inside and be adjacent, so that is false. They are not adjacent.
I remember you saying that a little ago. Like,
Yeah,
live
can't,
inside.
can't live inside and be adjacent at the same time.
Yeah.
Okay, now 14 through 19 is the same thing. You're doing the same thing. You're determining if they're linear pair adjacent, but I think or neither. So we're gonna label these either adjacent, linear pair, neither, or both. So here's the first one. Number 15 is $16 is this way. 17. And 19. Okay, so we're tasked with either calling it adjacent, I'm going to abbreviate, or linear pair, or neither. Okay, I'm going to just so we learn them better, I'm going to put that they can be both. And then also we learned about supplementary. Like I said, we learned about vertical. We learned about complementary, but I don't see any 90-degree angles, so I'm not going to use that one this time. So let's take a look at this. First off, let's deal with the ones they want us to deal with. Adjacent, linear pair, or neither. Now here's the key to this. If they're linear pair, then they have to be adjacent. So if you name it linear pair, that's why they don't have both up there, because if it's linear pair, then it is adjacent. You don't have to repeat yourself.
So you can put both?
Yeah, I'm just using this part. These right here are just add-ons. This is for the test. This is just add-ons, so we get a grasp more of what we're dealing with. Okay, this one here, 1 and 2, are they adjacent?
No.
No. Why not?
They are supplementary, or.
Well, we don't know. We don't know their measurements.
Oh.
So remember, supplementary has to add up to 180. We don't know if they do or not. In fact, it looks like they don't. But, you know, they don't give us that, they don't form a straight line. So they're neither. Okay? So actually forget about these for right now. I didn't mean to be confusing, but forget about those right now.
Okay.
This is just for the test purposes. So it's either gonna be adjacent, linear pair, or neither. This is neither because you've got this gap here. Okay, so they're not adjacent. What about these two?
That one is adjacent.
Okay, they're adjacent. Do they form a straight line?
Yes.
Yes. So they're linear pair. Now, if you put adjacent and linear pair, I'm not going to mark it wrong. But remember, by saying they're linear pair, you're also saying they're adjacent. That's the only way they could be a linear pair.
Okay.
Okay? What about these two? Just choosing between adjacent, linear pair, or neither.
I would say neither.
Okay? They almost look like they're adjacent, right?
Mm-hmm.
But they're not, because here's angle 1. This is its sides. Angle 2 has 2 totally different sides. Okay?
Okay.
So they are neither. What about these two?
Linear pair.
Okay, but can you have a gap?
Oh, so that would be adjacent.
Okay, well let Here's angle 1, that's its sides. Here's angle 2, do they share?
No,
No, so they're neither.
not there.
Just always put it to the test, redraw them. Now here's angle 1, it's got these two sides. Here's angle 2, it's got two totally different sides. So and where they kind of make a trick out of it is, yeah, they formed a straight line, but they had this in between them. They had more there, they had a third angle. In linear pair is only two angles, that's why it's called a pair. Okay, here's two angles. Do they form a straight line?
No.
So we can rule out linear pair, but are they adjacent?
Yes.
I said that kind of timidly. So yes, they are adjacent, because trace them. Here's angle 1, here's angle 2. Well, I shared this side right here,
Okay.
so they are adjacent. Okay, how about these two? Do they look like they form a straight line?
No. Well, kind.
Yeah, if it's close, like if you're having to go, does it turn it all? Then yes, it's a linear pair. In this case, it forms a straight line.
But
They're
why-
adjacent.
They are adjacent.
They are. Here's angle 1.
Mhm.
Here's angle 2. They share this side.
So adjacent and a aluminum pair. No, aluminum pair is adjacent.
Right.
Okay.
Yeah, that's the only way it can be a linear pair.
And adjacent just has to be adjacent.
Right.
That's
The only
what I'm-
difference,
That's what I'm confused.
yeah,
between.
adjacent just means they share side, share vertex like this.
Okay.
The only thing that sets it apart and makes it a linear pair then is if when they combine them together, you got a straight line like this.
Okay.
So these are both adjacent. Okay, this is adjacent, but because this one forms a straight line and this one doesn't, this one you still turn, then that's why this one's only adjacent, this one gets bumped up to linear pair.
Okay.
Okay?
Alright.
Now, to go through the other is obviously if they're linear pair, then they're both. Okay, that's what I wanted you to see is you can't have a linear pair unless they're adjacent. Then supplementary, now you could go through and say, well, this one, any linear pair is also supplementary, they add up to 180. You could have, like this one, we were, wondering, well, if they had added up to 180, they would have been. So, that's different. The only one that's vertical is this one. That was the one from yesterday. So vertical is, they're across from each other. They don't have to actually be vertical like we are used to using the term vertical, because we could turn this shape and make them vertical. But when they're across from each other like that, that's the ones we did yesterday.
Oh, okay.
Vertical. But for the test, you don't have to name it that. So,
Okay.
where'd my paper go? Okay. So that gets us to number 20. Okay. Yesterday, we did 20 through 25, so leave those blank for right now,
Okay.
because I'm gonna skip forward and do the last 26, 27, 28, 29, 30, and 31 on the camera, on the video, and if we have time, then I'll get you caught up. Otherwise, you'll watch the videos that I posted for yesterday, and those will go with those there, and catch those up, or catch some of them from class too as well. If we got a little time, we'll do it, but let's do 26. Now, so far, we have not done any problems where we're solving for x. But that's why we did that pre-algebra practice at the beginning of our class, because now what they're going to do is they're going to take all this knowledge that we just did with adjacent, linear pair, and all that, and complementary, supplementary, and they're going to mix in some pre-algebra basic formulas in that. Okay, so now we got to take that knowledge we learned in pre-algebra and mix it with what we just learned in geometry. Okay, so it's nothing new. It's not any new material, like, whoa, I've never, that's totally new. I didn't learn how to solve for x or something. It's just taking what we learned last term and putting it with what we're learning this term, okay? So this says each pair of angles is either complementary or supplementary. So that means if they're complementary, they add up to 90. That's knowledge we're going to use. And if they're supplementary, then they're going to add up to 180. They're
C before S.
C before S, very good. 90 before 180. Now, how we tell the difference is, you know, supplementary is going to look like a straight line when it's done. Complementary is going to look like a 90 degree. Okay, so that's how you can tell on the picture. So those are pretty drastic difference. Obviously 26 looks like this, so it's complementary. 27 looks like this, so it's supplementary. Okay, so that's how you tell the difference between the two. So let's put 26 up there. Okay, they've got it drawn upside down, which is fine. You can turn angles any way. And then they've got this one being, they tell us is 15, and this one they tell us is X. Okay, and the directions say what we're doing here is finding X, finding the value of X in each of these figures. So first off, once again, is it complementary or supplementary? This drawing.
Complementary.
It's complementary because it's got a 90-degree turn. So that means both angles together, added together, equal 90. We're going to use that to our advantage. Because remember, to solve for X, we need it equal to something. Well, they're telling us this one plus this one equals 90. That's what they're telling us by telling us it's complementary. So that's how I'm going to set it up. I don't know what this one is yet, right? That's why they used a variable. That's why they used a letter. So it's X. And if I add it to this one, which they are telling us is 15, those two together, added together, equal 90. There's my equation. Make sense?
I think so.
Okay, so this angle plus this angle equals 90.
Okay.
Now, so that's the geometry part. It's just setting it up, right? We learned that two angles added together to make this 90. That's the geometry part. The pre-algebra part is now I need to solve for X. I need to isolate the variable. So what do I need to get rid of on this side and put it over on this side? I want X to be by itself. So what do I need to move over here, The 15. How do I move that?
By, is it subtract, or?
Instead of adding, it
No,
is,
underneath the 15,
and
you subtract.
subtract. And if I do that over here,
You do
I have to
as
do it
90.
over here. See, it's all coming back. This is why we reviewed this at the beginning, so that now we can put it into practice. So that's going to cancel out, and X is going to be 75. And there's my answer. There's my value of X.
Okay.
Okay? Now, they're not all going to be that easy, but that's the first one. Okay?
Okay.
Second one is almost that easy, so let's do it. 27. Okay. So this one is complementary or supplementary?
Supplementary.
Okay, so instead of equaling 90, it's going to equal 180. Okay? And if I add the two together, that's what gives me 180. So it's going to look like this. X plus 20 gives me 180. See where I got that? That angle plus that angle. See, that angle is X plus that angle is 20
Yeah.
equals 180. Now, how do I move that 20?
Subtract it
Okay, same thing.
and then subtract.
Yep. And X gives me 160. There's my value. And you can always recheck that, put it back in. That's a 160 degree, that's a 20 degree. Therefore, I have 180 degrees when I put them together. Okay? Well, open this door over here. Now we're going to get a little bit trickier. But I promise you, you kind of get a feel for it. It doesn't have to be overwhelming, okay? Now, obviously, now when you're mixing in pre-algebra to it, not only could you make a math mistake with the geometry part, but now you could also make a math mistake with, so you gotta be real careful, you know, with your equations. So here's one that's got these, and we're gonna learn about parallel lines later, but we don't really necessarily need to know that yet. But here's 6x plus 7. That is what this degree is. 3x plus 38 is what this angle is. And they want us to solve for x. So we went from 0 to 60 really, what they did right there. And this is number 28. So, looks kind of daunting, but I promise you if you break it down and use reasoning here, you can solve it. We got to first determine is it equal to 90 or 180. Well, just take this angle alone right here. This angle right here is this angle right here, right? That already is bigger than 90. See how it's obtuse, how big it is? So it's not going to be equal to 90.
Okay.
And they've told us it's either going to be equal to 90 or 180. So if it's not equal to 90, then this whole thing is going to be equal to 180. I need more space than that. So that's the first hurdle, right? To say, okay, this angle alone is already above 90. So it's got to be 180. Now, the harder part is, now we've got both of them have x in it, whereas before, one of the angles at least was just a number. Okay, so here's this angle. That is the value of this angle. We don't know what x is yet, but that is the value of this angle. So that's my first angle, 6x plus 7. Okay, I'm going to write that down. 6x plus 7, that's one of the angles. And then I add in the other angle. So I'm going to add in the other angle. Plus, that's adding it in, 3x plus 38. Okay? So that's this angle plus this angle. So you see where I got those? So I'm going to, now, here's my equation. It's long, but there it is. This angle plus this angle equals 180. So we got a little more work to do. First off, you want to combine anything that you can combine.
6x, 3x.
And that is 9x. Remember, this is where I cross them out so I don't repeat myself. And then 7 and 38 is 45. Okay, it's still equal to 180, that's not changed. But now it looks a little bit more doable, right? Okay, now I need to move this 9 and I need to move this 45. Remember we talked about if you divide by 9 first, you're going to have to divide the whole thing by 9. So the easiest thing to move first is this 45. So how do we move it? Instead of adding it?
Subtract 45.
Okay. So now we've left with 9x equals 135. Okay. Now I need to get rid of this 9. It's not being added, so we're not going to subtract it. It's being multiplied. So what do we do instead of multiplication?
Divide.
Divide. Divide both sides by 9. That gives me x equals, that is 15. A little more work, but it's the same. You know, we did all this at the beginning of class to review, but now you're just plugging it into a geometry problem. Okay, 29. Okay, they give us that little box, so they're saying it is 90. I'll let you keep writing that. Gatorade. Math gets me more tired than PE. Okay, number 29. So is that supplementary or complementary?
Complementary.
Complementary, so it's equal to 90. What are my two angles that I'm going to add together?
6, or, yeah,
Yeah,
6.
either order is fine.
And
5x minus 9.
Yeah, 5x minus 9.
Okay, so that's that one, that's that one. Okay. We can combine these two, right? That's 11x. Okay.
Okay.
Now how do we move the 9?
Add the 9.
Add the 9. There's a difference there. We're going to add the 9 this time. And then how do we get rid of that 11? It's not being added, it's not being subtracted.
Divided.
Yeah. It's being multiplied, so we're going to divide it. And that's going to give me x is 99 divided by 11 is 9.
Okay.
Okay, number 30. This one's going to be supplementary. So they're going to add up to 180. So here's my equation. Now we know how to set that up. 7x plus 10 is one of the angles, 3x the other one. That's going to equal 180 because they're supplementary. So I'm going to combine my x's. I'm going to move my 10. And I'm going to divide by my 10. So it's the same thing over and over. They look different, but you're kind of repeating the process here. So I'll do number 31. Is complementary. It's a 90-degree angle. So they're going to add up to 90. There's that angle, 4x plus 3. There's that angle, x minus 8 equals 90 in this case. I'm going to combine my x's. That's 5x, because remember that's a 1x. And then 3 minus 8 is negative 5. Okay. And instead of subtracting 5, I'm going to add 5. And then instead of multiplying by 5, I'm going to divide by 5. And x is going to be 19.
Okay.
So just repeats that process. As long as you know some add up to 180, some add up to 90, you kind of know what they look like. That helps you set it up right. And then you just make sure you do your math right, from that point. We are not doing the 2 bonus.
All right.
So you can cross those out. I'm going to go ahead and shut the camera off because that's all of the ones that they needed, that everybody needs. And you can, this will go up on Google Classroom so you can watch this later if you want.